Hi, hello everyone. Welcome to SK Academy of Mathematics. Today we are going to solve the problem on Weddle's rule, where they have given the set of integral function. See, considering without integrating the integral function, we are going to represent the approximate value of the given integral function with respect to the given set of limit points. Okay, how to represent the approximate value of the given integral function without integrating, and how to verify by using Weddle's rule, I am going to show you now. First, let us represent the Weddle's rule. Weddle's rule is given by solution Weddle's rule is given by integral x naught to x naught plus n into h y dx, which is equal to 3h divided by 3h divided by 10 into y naught plus 5 into y1 plus y2 plus 6 into y3 plus y4 plus 5 into y5 plus y6. Till here we can consider up to 6 interval. If they have given 12 intervals, plus y6 plus 5y7 plus y8 plus 6y9 plus y10 plus 5y11 plus y12 goes up to etc. plus yn minus 6 plus 5 yn minus 5 plus yn minus 4 plus 6 yn minus 3 plus yn minus 2 plus 5 yn minus 1 plus yn. At the point, this is the standard representation of the Weddle's rule, where the first term represent till the 6 interval, next second term represent 12 interval, goes on up to n set of interval. How much they have given, corresponding to that you can represent the Weddle's rule formula. Consider this Weddle's rule formula itself, we are going to represent the solution of what integral function 0 to 5 1 by 4x plus 5. How? First let us see. After representing the Weddle's rule, see, we are supposed to represent the Weddle's rule formula. After representing, let us represent the given integral function. What is that given? I which is equal to integral 0 to 5 1 by 4x plus 5 dx. This we can represent it as x naught to x naught plus n into h y dx. What the point? Let us represent term by term. So let us consider that is x naught. X naught represents 0. X naught plus n into h, which is equal to, see, lower limit 0 and upper limit is 5. Then y represent 1 by 4x plus 5. This I can represent it as y equal to f of x. Got the point? Y equal to f of x. Then we have n. See, they have given 7 ordinates, but in Weddle's rule n should be the multiple of 6. See, n, please keep it in the mind, n should be multiple of 6, but they have given 7 ordinates. So what I am going to do, ordinates minus 1, n equal to 7 minus 1, n equal to 6. See, now you can consider n equal to 6, which is a multiple of 6. To simplify the term, x naught 0 plus n 6, h equal to 5, h which is equal to 5 by 6. Got the point? H equal to 5 by 6. Now, considering this term, now we are going to represent the interval. What are the interval? That is with respect to x, y. See, x represent the interval, and corresponding to that interval, the functional value is defined with respect to y. What is y? Y I can represent it as f of x, that is 1 by 4x plus 5. Done. Now we are supposed to represent the interval starting from 0 and ending till 5. Between this interval, it should have 6 interval including 0 and 5. Difference between these interval, that is we call it as common difference. The h we call it as the common difference. Common difference between this interval should be 5 by 6. Starting from 0 ending till 5, the common difference between this interval should be 5 by 6. How to represent the interval? How to represent the functional value with respect to the given interval? I am going to show you now. Okay, first take the calculator, press mode setup, press 7, f of x which is equal to, I have told you, 1 by 4x plus 5. Press numerator denominator 1 divided by 4 x. To press x, alpha closing bracket x plus 5. Press equals, start I told 0, end should 5, and the step should be 5 divided by 6. You get the values. See, 0, 0.833, 1.666, 2.5, 3.333, 4.166, 5. This is the interval. Corresponding to this interval, we have got the function value, that is f of x or y. Let us represent. Okay, x represent the values of 0. For value of, okay, before that, the value of 0, for the value of 0, I have, for value of 0, I have 0.2. Next, for 0.8333, I have 0.12. 0.12. Next, I have 1.6666. We get 0.0857. Next, 2.5. For value of 2.5, we have 0.0666. 3.3333. We get 0.0545. Next, 4.1. Okay, 4.1666. We get 0.0461, and the last, the 5, we get 0.04. Okay, 0.45, 0.857, 1.2. Okay, this I can represent it as y0, y1, y2, y3, y4, y5, y6. See, we have got 6 interval and 7 ordinates. 1, 2, 3, 4, 5, 6, 7, including the term 0 and 5. Represent the table so that while simplifying the terms, there will be no mistakes. Okay. Okay, after representing the table, now let us represent the terms of the Weddell's rule. Using Weddell's rule, we have integral x naught to x naught plus n into h y dx, which is equal to 3h by 10 into, since the nth term is 6, just we are going to consider y naught to y6. That's it. That is y naught plus 5 into y1 plus y2 plus 6 into y3 plus y4 plus 5 into y5 plus y6. Close the double bracket. After this, let us represent the terms, that is integral 0 to 5 1 by 4x plus 5 dx, which is equal to 3 into 5 by 6, 5 divided by 6 divided by 10 into y naught. What is y naught? I have 0.2 plus 5 into y1, 0.12 plus y2, we have 0.0857 plus 6 into y3, 6 into y3. What is y3? 0.0666 plus y4, 0.0545 plus y5, 5 into y5, 0.0461 plus y6, we have 0.04. Close the double bracket and let us represent the solution. Integral 0 to 5 1 by 4x plus 5 dx, which is equal to, by using the calculator. Okay, now before that, let us represent the value of 3 into 5 by 6 divided by 10. Okay, now let us see. To represent 5 into, see, we are going to use the calculator. What? 3 open bracket into 5 divided by 6 whole divided by 10. At the point, next open double bracket, we can represent directly, that is 0.2 plus 5 into 0.12 plus 0.0857 plus 6 into 0.0666, close the bracket, plus 0.0545 plus 5 into 0.0461, close the bracket, plus 0.04. Please always check once whether the values you have given correct or wrong. Press equals, you get 0.4025. We get, directly we get 0.4025. Okay, this is the required approximate value of the given integral function 1 divided by 4x plus 5 dx without integrating. Whether this value is correct or wrong, how to verify? That is, just go with the calculator, press integral function. Okay, after integral function, 1 divided by 4 alpha closing bracket x plus 5. Press lower button, limit is 0, upper limit 5. You get 0.4023, which is the approximate value of the given integral function. Verify, where you get integral 0 to 5 1 divided by 4x plus 5 dx, which is equal to, you will get 0.4023. Okay, done. See, this is the integral value, this is the approximate value with respect to, by using Weddell's rule, without integrating the integral function, we have got approximate value. What do you mean by approximate value? The whatever we get the value, it will not be exact, but it will be approximate. What do you mean by approximate? It will be similar to the integral value. This is how we can conclude that the approximate value and the expected value are same. First, let us go with the starting. First, represent the Weddell's rule. This is the standard formula of the Weddell's rule. After representation of Weddell's rule, represent the integral function. After representation of the integral function, represent the terms lower limit, upper limit, function value and the ordinates. Always remember the n should be the multiple of 6 in Weddell's rule. Then represent the value of h. H represent the common difference or common interval. Considering the set of functional values, represent the tabular column. X represent the interval. Y represent the functional value with respect to the interval, and we can represent y0, y1, y2, y3, y4, y5 and y6 till the interval. Whatever we have got, represent the Weddell's rule. After this Weddell's rule, represent the terms which are required. Simplify using the calculator. I have taught you in the video. Simplify, represent the solution, verify using the calculator. Then you can conclude that whatever the required integral function value is approximate. This is how you are supposed to represent the solution in the main examination or the internal part. For more videos, please do like, share and subscribe. See you in the next video. Thank you.